and start to share my screen. Okay, so someone is asking that, can you send it through Gmail? Yes, of course. You can type your Gmail privately to me, so you can put the Zoom direct chat so that I can see your email address so that I can send it to you. Okay. And okay, cool. I got it. So I will send you after we finish this session. Okay. All right. So let's start. Today it's our 6 days. It's actually the second last day because tomorrow will be the last day. Right. So you are almost done. You're almost finished here. Our topic today would be inequalities. So let's start. And I don't need to introduce myself to you because you are already very familiar with me. So let's try to solve our first inequalities together. So I just picked the first question of question number 5, and we are going to do this together. So solving inequalities will be really similar to solve equations as we did yesterday. So what we're going to do, of course, is trying to simplify them. So let's try to say if we are going to -8 for both sides, it will turn it to this form, right? So we can write it down as 3x is less than 5. So that means x should be less than 5 divided by 3. So that would be our answer, which is pretty clear, right? So what there is the difference between the inequalities and the equations when you are trying to solve them? One thing you should pay more attention to the inequality is that you need to pay attention to the change of the inequality sign. So for example, here you can see that the coefficient for this x would be a -5, right? Because you got this kind of negative symbol, that means if this kind of negative symbol should be involved within the operation, we need to pay attention to the inequality sign, the change of that. So let's try to solve them together to see how should we do that. So of course we know that we can like divide it by -5 for both sides, right? So if we are going to do that, if we divide it by -5, that would make the left side be x directly. And for the right side, it will be this form, right? This form is equal to -3. So as I said, we should actually try to change the inequality sign. So how should we do? Because we got a minus sign and we put this minus to the right side. So that means we're going to shift it to this term. And more importantly, because this is not actually less than, but less and also equal to. So you will keep this kind of equal to as well. So you only change the direction. You don't need to change whether it is equal to or purely larger or smaller. Okay. So our answer for this question would be x is larger and maybe equal to -3. Okay, so that is about the change of the inequality sign. Let's move on to our next question. So our next question will focus on the fractional coefficient inequalities. So fractional coefficient inequalities, that means you at least involved with the operation of the fraction at this time. So you can see that on our left side for the question number 1, here is the 3 as the denominator, right? So that means the left side is actually a fraction. So what we are going to do is trying to move to trying to eliminate that kind of fraction. We don't need that kind of fraction because it will make the operation be more complicated. So what we are going to do is multiply by 3 for both sides. So what we can get is 2x minus 1, which is less than 9, right? So that means 2x is less or equal to 10. So x should be less or equal to 5. Okay, so this is our answer for question number 1. And let's move on to the next one about how to simplify the fractions. So for our second question, for question number 7, what we can do is to notice that the denominator is very different here. For the first one, we get 3. For the second one, we get 2, right? So what we can do is to remind ourselves that how should we get the same denominator? I mean, put the denominator as 1 as a final result. So we need to find out the LCM. You remember the largest common multiplier, right? So what is the LCM for 3 and 2? Because we can notice that 3 and 2, both of them are prime number, right? So we can directly multiply them together to get 6. So we need to put 6 to the both sides. So if we are going to doing this to multiply 6 to the both sides, we will get this, right? And we are going to do the left side. So the left side, if we got 6 to multiply this x divided by 3 here, that would turn it to be 2x. And for this part, we get 3 left, so that would be this one, right? And the right side, we don't need to change that. So we are going to do one more step to simplify these polynomials on the left side. So that will be turn it to this form, right? So now you can write a final 1 as a negative x, which is more than or equal to 21. So what we need to do is, of course, we notice that there is a negative sign here, right? So what we are going to do for the x is to change the symbol to the other direction, which is this one. So this is
黄一凯，立刻来！现在有个东西，拿我手机来。
Okay. All right. Let's move on to our next question. So for our next question, we're talking about the number lines. So we're going to use number line to represent inequalities. So if you're going to talk about the number lines, there are some very basic knowledge about that. To represent something on the number line, for example, if we are going to talk about the x, let's try to do something here. If we are going to say that x is less than -2, for example, we are going to draw a number line here, and we mark down this is -2, right? And because x is less than -2, we know that x will be here. So that is how we mark x is less than -2 on the number line. For another situation, if x is larger than 2, we will mark down on the number line as this is 2. And this is how we do to represent x is more than 2. And notice that because there is no equal to, so when we are doing the representation on number line, we put this kind of a circle instead of a solid kind of board, right? So, okay, if we know how to draw a number line, we are good to talk about these questions. So for these questions, we are going to figure out what does this number line means. So firstly, we get this 4 and we get this -2, right? So that means x is within this part. Okay, so let's see. What is the exact relationship between x and -2 and 4? Notice that this is a hollow. This is just a white circle, right? So that means this is a kind of this symbol. And for this 4 here, it is a solid black circle, which means this symbol, right? So it can be equal to if you see the circle is in black color, or you can see it is a solid one. Okay, so we are going to write it down as this -2, and because x should be larger than this -2, we can put x here. And also we know that 4 in this part on this side, and we know that x is less 4 equal to 4, so that is how we write it down. So the answer should be, I think that is B, right? Okay, so if we don't have any questions here this time, we are going to do the most challenging questions for the MC problem. Now, let's take a look at question number 8, which is from a MC question. So we get non-zero real numbers x, y, a, b. There are 4 of them, right? And we know there is a kind of relationship between each other, which is x is less than a and y is less than b. So the question is asking that how many of the following inequalities must be true? So here we got 1, 2, 3, 4 of them. Let's check them one by one. So let's try to figure out the first one. So what we know is that x is less than a and y is less than b. We don't know the exact relationship between x and y or a and b. But you can see that in these inequalities, we got x plus y on the left side and a plus b on the right side. So how should we build connection between each other? Okay, so let's try to figure out and how should we figure that out is we are going to draw a number line again. So here we draw our first number line and let's put x here. We only know the relationship between a and x, which is a is larger than x. So a should be sit on the right side, right? So that is our first number line to represent x and a. Let's draw a second number line. And let's draw y here. So we know that y is less than b. So which side should b located on? Of course, b should be on the right side of y because b is larger than y, right? Okay, now we can represent them because we know that a is larger than x. And how much that a is larger than x is represented by this part of distance. So let's try to find some letters to represent this distance here, right? Let's say probably we can use a letter as k, right? Because this distance represent a, represent how much a is bigger than x. So that means k must be larger than 0. So we can do the same things for y and b. So this distance, we can use another value, another letter to represent the value of it, let's say probably air. And we know that air is also a positive number, right? Okay, so we can represent A now as A is equal to X plus K. And we can write B as equal to Y plus air. Okay, so now we get a kind of representation for A and B. And we know that for our equations here on the right side, we need to plot them together. So A plus B would be X plus K plus Y plus air. So that would be X plus Y plus K plus air. And we know that this K here, which is larger than 0, that means it is a positive number. And this is also another positive number. So that means the sum of X and Y and K and air must larger than X and Y. Okay, so that means, of course, X and Y together are less than A and B together. So the first statement would be true. Okay, so let's try to figure out the next statement. We need some extra space for scratch paper, so let's scroll down and make some notes here. So our second statement said X minus Y, which is less than A minus B. Okay, if we check our number lines here, we can see that it is pretty hard for us to compare the value if we do a kind of subtraction, because we don't know whether X is a positive number, whether Y is a positive number. We don't know, we have no idea. So what we can do for this part right now is trying to figure out, are there any counterexample to disprove that this statement? So that means, are there any example can prove that this one is incorrect, right? So let's try to figure out. If we say like, so if we say X and Y can be equal to each other, right? Because we don't know. So we can, of course, we can say, yeah, maybe they can be equal to each other. So let's try to set as this one. So if we got A is equal to 2 and X is equal to 1, right? That is true because we know from the number line here. Okay. And let's say that B is also equal to 2 and X is, Y. Oops, hold on. That Y is also equal to 1, right? So let's say all of them, A is equal to B, X is equal to 1. But we keep the only relationship we know, that A is larger than X and B is larger than Y, right? So now what is the result for our statement here? So X minus Y would be 0. And also A minus B also equal to 0, right? So that means X minus Y should be equal to A minus B. This is a kind of counterexample for this statement, because this statement said that X minus Y must be less than A minus B. So our example here disproves it. So that means it can be a kind of false statement. Okay, we can use the same logic for the next one. Number 3, we are going to figure out whether are there any counterexample. So let's say X multiplied by Y, which is less than A multiplied by B. As we said, we don't know the X and Y and A and B, whether they are positive, whether they are negative. They can be like one positive, one negative, we don't know. So let's try to suppose the value of it in any way we want to do. So let's say maybe A could be equal to -1, right? And let's say that X could be equal to -2. So this situation also can follow our number line here, right? So let's move on to b and x. So let's say b is also -1. I'm kind of lazy. I'm always trying to set them to be equal to each other, but that's totally fine. Because we are free to set what is the desired value then. Okay, let's say for this situation, we got x and y, which is equal to +4, right? Oops, what happened to my pencil? Okay, got it. +4. And for a and b, we multiply them together, we got +2, right? So that means x multiplied by y should be larger than a multiplied by b. This example also disproves this one here. Okay, all right. Finally, our last one. We're also going to trying to figure out the this statement following the same way. Okay, so if we said that let's keep probably the same value as we did for statement number 3. So let's say a and x, they are -1 and -2. B and y, they are -1 and -2. So x divided by y should be equal to 1. And we got also a and b, they are 1 as well. So that means they're the same. They're equal to each other. This example also disproves this one, which proves that we got more situation than this one, right? So this statement is also false. Okay, all right. So we get 2, 3, and 4, they are false, and only the first one is true. That means we got how many statement is true? We got only one of them is true. So B would be the answer. Okay, that is a little bit hard to do our last question, but always remember that if we need to prove one statement is true, only what we need to do is to try to figure out are there any counterexample to disprove it. So that is how you can say, okay, this statement is not true. Okay. All right, so that's all for today's question. Do you have any question now? And also, I think that I can stop recording.